Good morning. Today we are going through packet number 10. Packet number 10 is due on the 11th, the day we come back from spring break. So we need to make sure we are working on this. Easter break. One of these breaks. Okay, so the day we come back from Easter break. So let's look at our first page. A machine at a local factory has 3 gears. One gear must be replaced every 3 months, another every 5 months, and the third every 6 months. All of the gears were just replaced in September of 2016. In what month and year will all 3 gears need to be replaced at the same time again? So we know we've got the 3 types of skip counting. We're counting by 3s, counting by 5s, counting by 6s. So what is the common multiple, the least common multiple that they have? It's really hard to know when we're going off of the calendar months. We're not just skip counting up to the same number and saying, oh, that's my answer. We have to work it out with the calendar where that falls. So the way that I found to do it that was the easiest for me, there are multiple ways you can answer this. My easiest way to look at it was I wrote out my calendars. I started at September, so the year 2016, and I started with September, October, November, December, January. Oh, no, not January. That's the next year. Then we have 2017, would start with January, February, March, April, May, June, July, August, September, October, November, December. Then we have 2018. I did the same thing, January, February, March, April, May, June, July, August, September, October, November, December. Then what I did was I did my skip counting. So I gave each one of these a different thing that I was going to do. So maybe every 3 months, I'm gonna circle it. So every third. So we all started in September, they were changed. So I'm gonna circle that one. So for every 3, I'm going to circle. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So then I chose something different to do for my 5 months. I'm going to cross off. So everybody was changed in September. So I'm going to cross off that one, and then I'm going to do my skip counting. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. And then I have to do every 6 months. So I'm going to underline every skipping by 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Is there anyone that has all 3 of them on it? So what do you think I need to do? Do I just stop and say it never happens?
No, wouldn't you keep going up?
Keep going. So I'm going to add on 2019 and write out those months and keep my pattern going until I can find that month that has a circle, an X, and an underline. So you're going to keep going with your pattern. So it might help you if you're actually following along and doing this on your paper right now, right, Riziki? So I'm not asking us to, showing us what to do just for the fun of it. You can follow along and be doing this so you don't have to watch the video later. But you are going to want to continue that pattern until you find the one that all 3 get changed on the same month. So let's go to our next page. JT, did you find yours? Are you sure, or do you need a new one?
I worked on it yesterday.
Okay. Our next page, Keith baked muffins and gave 3/4 of them to Peter. Peter then gave away a dozen of the muffins, and Peter ended up with 6 muffins left. How many muffins did Keith bake? I'm always big on my bar models when I get these word problems. So if Keith baked muffins, so these are all the muffins that Keith baked, but we don't know how many that is. That's what we want to find out. He gave 3/4 of them to Peter, so how should I divide up my bar?
3 by 3/4.
By 4s. So these are all the muffins I'm dividing by 4s, and he gives 3 of them, 3 out of the 4 he gives to Peter. So Peter gives away a dozen, and he has 6 left. So how many muffins did Peter have? So how many did Keith give to Peter?
Oh,
18, because he was able to give 12 away and he had 6 left, so that means he was given 18 muffins. And we have 3 sections. So how do I figure out how many muffins are in each section? Say it again, Luciana.
Divide by 3.
I'm going to divide it by 3.
Wow.
So I know one section is 6. So I can fill in that 6 for each section. Can I then figure out how many Keith made all together? So when we draw that picture and we figure out what information we're given and what we can do with that information, we're able to use it to figure out the unknown. So we're able to figure out how much Keith made all together. All right, our next page is our 5-card challenge. I still have people that are putting multiple equal signs into one equation. That's not how an equation works. An equation only has one equal sign. So I need everybody on this page. So we're all hearing this. So everybody should be on the 5-card challenge page. Everybody should be on the 5-card challenge page. When we write an equation only has one equal sign. So we could do something like 10 minus 1 minus 7 equals 2. We don't want to say 10 minus 1 equals 9, 9 minus 7 equals 2. That doesn't work because we have multiple equal signs. There should only be one equal sign in your equation. You can do this off to the side to work it out, but your final answer should only have one equal sign. Does that make sense? Okay. Next page. It is our pattern block page. So it says math 6 for the 7th figure in the pattern. How many blocks will there be in the outermost layer and what color will it be? So we have yellow, we have pink, we have blue, and we have red. First thing I did was I numbered my figures. So I said, okay, this is figure 1, figure 2, figure 3, figure 4, figure 5, and I know that I need to go to figure 6 and figure 7, and I can stop at figure 7. Then I went through and I filled in from the figures that they gave me. And when you're doing the pattern blocks, you're always looking for patterns. So let's see if we can find any patterns. How many yellows are in the first figure?
1.
How many pinks?
0.
How many blues?
0.
How many reds?
1.
There's 0 reds.
Yeah, total is 1.
Total is 1. Okay, so let's look at figure 2. How many yellows?
1.
How many pinks?
9, 10, Six, seven,
1, 2, 3, 4, 5, 6, 7, 8 pinks.
Knew it.
I said 0 blues and 0 reds. There are 9 total. But only 8 of them were pink. So now if we look at figure 3, we still have 1 yellow. Those 8 pinks. How many blues do we have? Nolan? 16 blues. Still no reds. So how many total? 25. Now let's look at figure 4. Still 1, 8 pink, 16 blue. How many reds? 24. How many altogether? 49. So let's look at figure 5. How many yellows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 30, 33. So there were 32 on the outside, plus the 1 in the middle. So there are 33 yellows. Because we count the one that's in the middle and the 32 on the outside. How many pinks? Pinks didn't change, there's still 8. How many blues? That doesn't change. How many reds? That hasn't changed. So how many is that all together? 81. So now we need to look for patterns to help us fill in the rest of our chart. The first thing I did when I was making my answer key was I looked to see what color is that outer layer going to be in the 7. So we got yellow, pink, blue, red. Yellow. Oh. So we know that it goes yellow, pink, blue, red. Yellow, pink, blue. That helps us answer that. We're not saying answers right now. I'm just, which pattern do you see, Aiden?
I see that you're going up by 8 each time. No, what? No, 9 plus 8.
I see where you're going with that.
It's 9 plus 16.
That's part of a rule, but there's more to it. Okay, so 8 does play a role, but there's a lot more to it that we don't have to get that in depth. Do you see a pattern?
I see a pattern in the total number.
What do you see?
It's every odd number, like times 5.
Oh, Mrs. Gambino's favorite numbers. What do we call that when we're timesing it by itself? Yeah, we're squaring them. So, and Isabel said, hey, look, it's the odd numbers are squared. 1 squared, 3 squared, 5 squared, 7 squared, 9 squared. What's our next total going to be? 11 squared. What's the next total going to be?
13 squared.
Do I need to go any farther? No, we only worry about that 7th. We don't need to do anything underneath it. So you can fill in the total. What other type of pattern do we notice? Look at going from figure 1 to figure 2 to figure 3 to figure 4. What do we notice about our yellows?
They stay the same.
For how many times does it stay the same? 4. We can see that there are 4 here, 4 here. It stays the same for 4 times. So if this is 33, what's this going to be?
33.
And what does this one have to be? 33. And we know we don't have to do the 8th row, but we know it's going to be 33 because it goes every 4. Do we know what comes next here for the pink? 8. 1, 2, 3, 4. It's going to change because remember we add pink to the outside. So we don't know that one off the top of our heads. Do you have your packet, Jillian?
It's at my house.
You're sure?
Yeah.
Okay. If you want to get a piece of loose leaf so you can be writing stuff down, you can. What about the blue? 1, 2, 3, 4. So we know that one's going to be 16. And our red, 1, 2, 3, 4. We know these ones are going to be 24. We can fill in our totals. So if I know my total, and I know how many yellow, blue, and red, can I figure out my pink?
Yeah.
How?
Adding them all up.
And doing what with it? Gigi? Exactly. If we know the total, like for number 5, we know the total is 81. We can subtract out the other ones that we know and we're left with the one we're looking for. So if you can figure out the total, that 11 squared, you can subtract out the 3 that we know and you're left with the one you don't know. Then once we know that, can we fill this one in? Yeah, it's going to be the same. It's the same. Every 4 are the same. So you can do the same thing to find the blue. Figure out the total, subtract out the ones you know, and you're left with the color you don't know. Here's the trick. To answer our question, what color? Well, you're going to have to write that down here. It's going to be what color. You're going to write that color here. Then you have to know the outermost layer. So here's our trick. If you know this answer is at your outermost layer. Why not, Aiden? No, if we know what the color is this number the outermost layer? The total isn't the outermost layer. So look at my yellow, right? So I added onto it. I went from 1 yellow to 33 yellows, but remember, we had to count that inside one. We don't want the inside, we just want the outside of the figure. So what would we have to do to the inside? Subtract it out. That's how we get rid of it. We subtract it out. So if you know what color is on the outside, you're going to subtract out how many were on the inside, so you're left with just the outside. Does that make sense? All right, let's look at our next page. So there are 2 answers you should be writing on for this one: the color and how many are on the outside of the figure. So not just the color, not just the number. You need to see them both. Jillian? Yep. And what I want you to do is go back and look to see if you followed the same idea and get the same answer. Because we know there are a lot of different ways to do math. All right. In our last math packets, we've been having a hard time with nets. People aren't understanding how to create those nets. So for math 6, all we have to do is make a net of our triangular prism and label it. So we're going to open it up and lay it flat. What do you think that's going to look like? Bennett?
So you do the square or the rectangle in the middle, and then on the 2 shorter sides, you do like a smaller triangle, and then on the bigger sides you do one big triangle.
Oh, big triangle?
What did you do triangle? You do one rectangle. You do rectangle.
So is that what you were saying, Bennett?
Yeah. You do 3. You do no.
So
if
if we were to fold it up, if we are to fold this up, we get a triangle coming up, a triangle coming up, and then a big triangle coming up. Are these 2 sides going to line up?
No.
So when we do our net, we will always want to picture folding it up and making sure that they are going to line up. So I'm going to tell you, Bennett, you have this part, right? What else do I have to do, Olivia?
You put 2 rectangles.
If we look at our figure here, we have one rectangle on the bottom, one rectangle on this side, and one rectangle on the back side. So you are correct, Olivia, there are 3 rectangles. So now if we fold it up, this one folding up this way will match up with this one. This one folding up this way, and we fold up the triangle, they are going to match up. So we have to do our second part. So this is drawing the net, then we have to label it. So we have to look at our numbers and see where they go. So if I look at my triangle, I see one side of the triangle and this side, the 2 sides that are pointing up, they're 10s. So this is 10, and this is 10, this is 10, and this is 10. Because when they fold up, they're gonna fold up to match up. So they have to be the same number, because we want them to match up exactly the same. So it's gonna be the same thing on this side. So where does that 12 fit in?
Ooh.
Gigi?
The 10, the 12 goes in like the middle.
Like here?
Yeah. No.
Here?
Like the triangle.
So that's this. That's the 8. So this line right here is going to be the 8. The 12s are right here, the bottom of our triangles. So that's going to be right here and right here. So then what do I put on my long lines? X's. We don't know those. So we're going to put X's because that's what they have it labeled as here. That's the variable. We don't have to do any more. We just have to know how to label it. Always be thinking they need to match up. So this end has to match up with this end. When we fold it up, they have to be the same number. Okay? So if you were following along like I've asked us to do, you'll have the page done already. All right, our next one is our formulas page. So, same formulas that we've been using the last few packets, and then I'm going to give us some numbers that we can fill in, and we're going to solve them the same way that we've been solving in our last packets. So our formula for our rectangular prism is length times width times height. Formula for the cube is side cubed. Formula for the triangular prism is 1/2 the length times the width times the height. Our pyramid is length times width times height divided by 3. Our cylinder is pi r squared times the height. Our cone is pi r squared times height divided by 3. And the sphere is 4/3 times pi r cubed. You in Math 6 only have to do 2 of them. You don't have to do all of them. The bottom row is a lot trickier because we're dealing with pi and we're dealing with squares. So those are more challenging. If you're up for the challenge, work on those. Nolan. I'm sorry, what?
What's the cube one?
Side cubed. Or you could say length times width times height. They mean the same thing, but because it's a cube, each of those have to be the same number. So if it's side cubed, it means it's like 3 times 3 times 3. Okay, or if the length is 3, the width is 3, the height is 3, you just have to remember that it's always the same number goes in each of those lines. So here are some numbers to fill in to help you. For our rectangular prism, you could fill in the 3 and the 9. For our triangular prism, you could fill in the 14 and the 5. For our pyramid, you could fill in an 8 and a 9. For the cylinder, a height of 2. For our cone, a height of 36. So those will help you come up with the answers. Remember, we know the volume, we know the formula, so put in the variables that you know, it equals that volume, and then you do your opposite operations to find out what our missing variable is. So this is all about those opposite operations. All right, our next page. Turning the wrong way. Last page. Find the area of the shaded region. So the first thing we have to do is the area of our full figure. That is a rectangle. To find the area of a rectangle, you do length times width. To find the area of our triangle, we do 1/2 the base times the height. This is our base. This is the height. I don't have a number in the middle of that triangle. How do I find it? Where do we see the height, Jillian? 8 divided by 2 is not our height. Look at where our height is. Do we see another part of our rectangle that goes from here to here? Isabel? The side. It is the same thing. From here to here is the same as from here to here. So what is our height? 6. So if this is our base and this is our height, you put that into our equation and then you take half of it. So you need to find the area of the whole figure and the area of the shaded region. Matthew.
So we times base times width and cut it in half?
Yeah. Because remember, base times height, or length times width, that's square, and if we cut it in half, we are left with our triangle. So it's what we're doing. It just doesn't look quite so simple, but it is that simple. Okay, with that, I'm gonna stop our recording. You are watching at home. We hope you're well, and we hope to see you soon.